After that day, we have Wednesday, which is the exam day. The exam day at 8 a.m., we have no class. Don't come to class at 8 a.m. Wednesday. All what I want from you is to come at 7 p.m. to this room to take the exam. Okay? So Wednesday, no class at 8 a.m. Okay? Now, usually I run help sessions before the exams. All the rooms in this building, we're trying to reserve room somewhere on campus. It didn't happen. So to help you, because I know all of you, as we're approaching the exam, you're looking after everything, you're doing practice exams, you have a question. So I'm gonna give about 5 extra office hours within a week before and the week through the exam. So I'm gonna have, this is my additional office hours, so my old office hours gonna be the same. In addition to that, in the 5th of October, I'm going to be in my office ready to answer your question from 9 to 11 a.m. ISB 341. The 9th of October also, that means the day before the exam, I'm going to be from 10 to 12 and from 3 to 4 in my office for any question you have. This is for that. You can come, you and your friend, 3 of you, 1 of you, it's up to you. Up to you how you want to come. But at any time you come to the office hours, please make your questions ready. Okay, just make I need to go over this, and I want you, for example, to explain this concept, that concept, I have hard time understanding this or that. You can't come to my office hour and tell me, I don't know anything about what we've been talking about. That's not going to happen. I'm going to say, sorry, you need to go out, go learn the material, then come ask me about what you didn't understand. Now, for the key, in the key of moles, molecules, worksheet, there is a typo, and I corrected that typo, I changed it and put it back, uploaded back, but in case you printed out the worksheet before yesterday at 4 p.m., there was a kind of a typo in number 6. In the answer I put is 8 times 10 to the 23 or 24, I'm not sure, I forgot. The right one is 5. Anyway, if you do the calculation, it's clear that there is a typo in there, because if you do the calculation, it tells you definitely it's a 5. So it's clear it's a typo. Now, the last day to report that you have a conflict, an exam conflict, and it should be the same time, the same day, okay, is this Sunday, the 30th of September at 11:59. Any email I receive after 11:59 about, I have an exam conflict, I'm going to disregard, I'm not going to look at. The reason why all of you have definitely know when your exams are and when you have. So I'm talking about exam 1, I'm not talking about exam 2, 3. Okay? So if you have a conflict, you need to contact me ASAP before Sunday, 11:59 p.m. So with that, those are all the announcements. Let's get started with the precipitation reaction, which we were talking about. And we said that a precipitation reaction is adding 2 aqueous stuff. They are water soluble. Then we'll get a precipitate. Now, in the coming 7 slides, the question is, what is the precipitate? What I want from you is not to only figure out the precipitate. It's going to be very boring just to figure out the precipitate. What I want from you is, when I'm asking the I-clicker question, the first minute to just send your answer, what is the precipitate, and take the other minute to just write down the net ionic equation. Try to write down. It may be hard the first slide, the second slide, then it's going to get better the third, the fourth slide. Okay? So the last time we stopped at this one, I'm going to redo it because it was at the end of the lecture. So we had copper sulfate plus sodium carbonate. Both of them are aqueous. And I know that from the table, from reading the table. Then I added the copper sulfate to sodium carbonate. And as I said, in precipitation reaction, mainly it is a swapping anion. Okay? So this anion, which is carbonate, you don't need to do the I-clicker. You did this I-clicker. Okay? We did it. I'm just going over the answer. Carbonate and sulfate. And this is the anion. So what's going to happen that The copper gonna take the carbonate as anion and the sulfate gonna go to. And this is what I'm gonna do. I'm gonna say copper, carbonate, plus Na sulfate. And so first of all, I'm gonna figure out this is water soluble. Now for sodium sulfate, it is water soluble. But I have one thing that we didn't discuss when we reacted AgNO3 plus potassium iodide is the balance of the ionic compound. For this compound, we know for sure that sodium is group 1, so it has +1 as a charge. Sulfate, by now you should know that it has 2 minus, so I need to balance the ionic compound formula. So it is Na2SO4. Now let's go back to the copper carbonate. We want to make sure that it is also right. From here we see that copper sulfate. We know that copper is first that sulfate is 2 minus. For the compound, for the ionic formula to be copper sulfate, that means this is copper 2 plus to balance each other and have copper sulfate. In other words, from this formula, I figured out that copper is not 1 plus, is not 3 plus, it is 2 plus. Now, I know that copper is 2 plus, carbonate, I know it's 2 minus, so this is the balanced ionic formula. Okay? But that's not enough. I need to make sure that the whole chemical equation is balanced. I have one copper, one sulfate, one sulfate. I have 2 Na, I have 2 Na here, one carbonate. Now the equation is balanced. Now I can go to the net ionic equation. Before that, you can't go to the net ionic equation. So first step, determine what is the precipitate, what is aqueous. After that, balance the ionic formula of each product you're forming. Then balance the chemical equation. From there, we're gonna go to getting the net ionic equation. And in the exam, the question gonna be, what is the net ionic equation? For every slide I'm doing now, the question gonna be in the exam, what is the net ionic equation? Okay? So, as we said, how to go to the net ionic equation, everything that is aqueous, I'm gonna break it down into its ions. If it is a polyanion, it's gonna stay as a polyanion. If it is a monoatomic anion or cation, it's gonna stay as monoatomic. Let's start with copper sulfate. It is aqueous, so it is copper 2 plus Aq plus SO4 2 minus Aq, and I keep SO4 as it is, because it's a polyanion. Plus, now sodium, I have 2 sodiums, so it's gonna be 2 Na plus. What I see in exams, students put N2 plus. That's wrong. That's you telling me that the 2 sodiums have a bond and they have plus charge. That's wrong. The subscript gonna be the stoichiometric coefficient in ionic compound. Why I didn't do that for the 4 here of the oxygen? Because this is a polyanion. It's not a monoatomic. I do that for the monoatomic cations and anions. For the polyanions, I don't take the 4 and put, I have 4 oxygen. We don't do that. Plus CO3 2 minus Aq. Now, the copper carbonate is a solid, it's insoluble, so this is why it doesn't dissolve. It's going to be a precipitate in the beaker, it's not going to dissolve in the water. I have, this is aqueous, so it's going to be 2 Na plus SO4 2 minus Aq. Now my next step is to figure out what are the spectator ions. What are the ions that didn't change before and after? They are just there as an audience to balance the charge inside the beaker. And those gonna be, so 2 Na, it was aqueous before, 2 Na plus aqueous, it's 2 Na aqueous. It's not in a precipitate, it's the same thing, so I'm gonna cancel it. It is the spectator ion. SO4 2 minus, it is SO4 2 minus, it didn't change. What I cancelled are the spectator ions. Okay, whatever left, which is the copper 2 plus Aq plus the CO3 2 minus Aq to give me the copper CO3. This is the net ionic equation. This is what we usually ask you about in exams. Okay? And what you need to know if you need to balance the equation, if you're doing this reaction in the lab, you're going to be asked about this to calculate how much you're forming, how much. So these are the steps. It's not straightforward. You have 3 steps, 4 steps to get there. Okay? So you have to do that every time I'm giving you the next eye clicker, the precipitate. What is the precipitate? You're going to answer it in probably 2-3 seconds by looking to this. And after that, try to do this. Okay? So this is the net ionic equation. Now sometimes I see some of you thinking this is the net ionic equation. This is not the net ionic equation. The net ionic equation is only for the cation and the anion that is forming the precipitate. Okay? Now we're gonna start with an eye clicker. Again, the question, the eye clicker asks you about the precipitate. What I want from you is to write down the net ionic equation yourself. That's gonna help you get it easier and faster than struggling alone with ours. So I'm gonna give you 2 minutes. The eye clicker will You can definitely talk to each other.
I kind of have an idea, but I can't say that I can do it myself.
Okay, write down the net ionic equation. Let me see, I'm going to stop the eye clicker at 2 minutes, as I said. For all the coming slides, I'm going to stop the eye clicker at 2 minutes. Okay? Okay. I'm going to put this down. And I have 83% for CC is the right answer. Okay, so again, okay, as I stop the eye clicker, everybody should go back to silence. Okay? So I have Fe and O3 plus NaOH. Again, the idea is swapping the anions. So if I do so, I'm going to end up with FeOH. And it's not balanced yet, but I'm just swapping the anion for the minute. And Na and O3. Okay? Then I'll go to the table and figure out all iron, all OH are insoluble except if they have barium and so on. That tells me this is a salt. Because before going any further, I need to balance these ionic formula. Let's start with Na. I know that Na group 1, so it is +1, NO3 -1. That's you know it for sure, so this is the balanced ionic formula, the right ionic formula. For Fe, OH, I know that OH is -1. From this formula, I can see that Fe is a 3+. Can everybody see that Fe is a 3+ from this formula? Okay, so it is a 3+. That means to balance this one, I need, since it didn't, they don't cancel each other, it's FeOH3. I'm going to put 3 here, but that's not the end of the story. I need to balance the whole equation. So I'm going to start balancing this equation. I have one Fe, I have one Fe, I need 3 NO3. So I'm going to put 3 for the whole thing in there. Now I have 3 OH, 3 OH, 3 Na. Now it's totally balanced. Now I can think about the net ionic equation after balancing the ionic formula and the chemical equation as a whole. Okay? Now my next step is everything that is aqueous, break it down to its ions, and keeping in mind that polyanions will stay as they are. So Fe, so it's going to be Fe3 plus AQ plus, this is 3 for all of this, so I have 3 nitrates. This is why I'm going to put it this way. Plus I have 3 Na and 3 OH. So it's going to be 3 Na plus 3 OH minus. Now for this one, it's solid, and usually we don't break solid because they're going to be a precipitate plus 3 Na plus 3 NO3. Okay, so let's see the reaction. So Jake's going to show us the reaction. So we have, usually iron has this yellow color there, and the NaOH is just kind of colorless, so we're going to add them together. And definitely if we keep it enough, okay, you're going to get a precipitate, which is your iron. Okay, so this is the reaction. Now let's go to the net ionic equation. So now I have Fe3 plus, now it is in a solid, so I'm not going to change. It's not a spectator ion. I have 3 NO3 minus. That's going to cancel this because it's a spectator ion. It's the same before and after. 3 Na plus is the same before and after. So whatever left is my net ionic equation. This is the net equation. Okay, let's do one more. Again, the idea is to try yourself to do the net ionic equation in class. Okay, lead nitrate plus sodium nitrate. And let me just write the formulas for you. Maybe that would make it easy.
That's one of those ones that isn't equal one stuff, but I can't remember.
Crypto soluble.
Oh, okay. It's the same thing. You're just switching nitrates. Literally the same thing. Right. Yeah. So there's
Okay, so I'm going to stop it at 2 minutes and check your answer. And let's see. We have 76% of the class think there is no reaction or no precipitate, and let's see. Jake, can you show us? So we have lead nitrate plus sodium nitrate. Okay, so this is the lead nitrate plus the sodium nitrate. Jake gonna add them together. Nothing there. It's still both aqueous, nothing precipitated. And there is the right answer is no precipitate. Okay? So let's get started. First of all, this is aqueous and this is aqueous. So as I said, in a reaction like precipitation reaction, what's gonna happen is a swapping anion. Guess what? The anion is the same. So you're gonna end up with exactly the same compound. And even sometimes it would be a different anion, but if you swap it, it wouldn't give you anything soluble. And that is not a precipitate reaction. It's you're dissolving stuff in a beaker. It's not called a precipitate reaction. It is called dissolving stuff in water. Okay? This is the case of dissolving things in water. It's not a precipitate reaction. Okay? Okay, let's do this one. Again, I'm gonna stop it at 2 minutes. Try to write down the net.
It's -2, I think. It could be wrong. I don't think I saw my master in high school, but we had like a chart. Sorry, what did you say? Oh, okay.
Okay, let's see what you say. So I have 79% to be C. C is the right answer. Let's see the reaction. So it's copper sulfate. Whenever it is copper 2+, it's going to be blue in color. Blue in color. And then we have calcium chloride. It is water soluble and it is colorless. So we're going to add them together. Okay, so this one is going to take a long time. Jake found that it's going to take a long time to form the precipitate, so he prepared that for you already. And as you can see down there, the precipitate, it forms the precipitate, but it needs more time. Okay, what is the net ionic equation? So I gave you 2 minutes to figure it out. What is the net ionic equation? Yes, please. Very good. Ca2 plus. Two plus or two minus? Yeah, definitely. Thank you. That's exactly the net ionic equation. Thank you. So, the shortcut to figure out the net ionic equation, you can go through all the steps. Usually when I say the shortcut, everybody gets confused. Almost half of the class get confused. But I'm going to say it for Whoever likes it, they can use it. So, first of all, I'm gonna do the swapping, okay? So I'm gonna end up with copper chloride 2 plus calcium sulfate, and I'm gonna figure out that this is the solid, this is the precipitate, this is aqueous. In other words, the thing that's gonna form the precipitate, the net ionic equation is, it comes that the ions that is forming the precipitate gonna react with each other to form the precipitate. In other words, if you get the precipitate as a product and think about their anions, the cation and the anion that is forming it, that's the net ionic equation. I know that some of you are like, oh, no, that doesn't make any sense. But if you get what I'm saying, use this method. This is a fast method. This is a shortcut to figure out the net ionic equation. Is to think what is the precipitate after you balance the ionic equation, and from there say, okay, what are the ions from which this ionic compound is formed, and then you can think backward what is the net ionic equation. Anyway, I'm gonna go the slow way how to do that. So I swap the anion and I figured out that calcium sulfate is the precipitate. My second step is balance the whole equation. The whole chemical equation is balanced. Now I'm gonna look which dissolves in water and which not. So this is what dissolves in water, so I'm gonna take it into its ion. Plus Ca2 plus 2Cl minus Aq. To give Cu2 plus 2Cl minus, because copper chloride is water soluble, plus calcium sulfate, gonna be the solid one. And when I stop the eye clicker, you need to stop talking. And that's your last warning for today. Copper gonna cancel the copper. The two chlorides gonna cancel the two chlorides. So I end up with sulfate plus calcium to give calcium sulfate. This is the net ionic equation. Okay? So let's do, I think there is one more to do, which is this one in here. Try to write the net ionic equation of this one.
B.
It's B breaks rule number 3 on the sheet.
Guys, for the C, it should be NaNO3. For C, it should be NaNO3 instead of potassium. Okay, not KNO3. So choice C should be NaNO3, not KNO3. Okay, so I'm going to stop it out here and check what is the answer. And I have 90% for B. B is the right answer. Again, the same technique, I'm going to swap the anion. So I'm going to end up with NaNO3. And, okay, the NO3 is going to be swapped by. So I'm going to put PBI. But PB here has, from this formula, I'm going to figure out that lead is 2 plus, so that's going to be 2. So this is aqueous, and this is a solid. So the short, okay, let me go the long way. Okay, so NaI, so I'm gonna take it to Na plus I minus. Oh, before I go any further, I need to balance the chemical equation, the whole chemical equation. So I have two iodine there, so I'm gonna put 2 there. So now I need 2 sodium to balance it. Then I have to, now the equation is balanced. Now I can go further, so it is 2. So I minus AQ less 2 plus aqueous plus 2 NO3 minus AQ to give 2 Na plus 2 NO3 because this 2 goes in close. To give lead ion. So, okay? So then those are spectator ions. So whatever left is the net ionic equation. To give lead iodide solid. So this is the net ionic equation. Okay? With this, we've done from doing the precipitation reaction and the net ionic equation. If I'm you, I'll practice as it's easy for you to see me doing that, but you may do a lot. It's maybe a lot of small mistakes until you go to the you get the net ionic equation. So practice in OWL how to do the net ionic equations. Okay. Now the other kind of question that we're gonna see regarding the precipitation, I'm just gonna skip this one. Try to do it yourself. I think it's getting, and just 1 minute, we're gonna show you the reaction of sodium iodide with nitrate, and it's gonna give a very nice precipitator. It's gonna be a yellow, very nice precipitator. Okay? So you have the crystals. And this is what it's gonna form if you leave it for 1 night. Okay? Now, we're going to start with another kind of questions, which is this one. Okay? So, I'm going to give you 1 minute 20 to figure out what is that. What is the answer? If an aqueous solution of, so it's asking you whether it is A or B or C, is added to a mixture of barium chloride and iron chloride. So what you have is a beaker that you have in it barium chloride and iron chloride. And you go back to the table and you figure out both barium chloride and iron chloride are water soluble. So mainly you have Fe3+, Ba2+, and Cl-. Okay? Which one of these, so when you add one of these, either A, B, or C, the barium gonna precipitate. The barium gonna form a compound that's gonna precipitate, while the Fe3+ gonna remain in the solution. Find out which one is that. And definitely you need to use the solubility rules.
It's A, right?
Yeah.
Do you need some more time?
Yeah.
Okay.
It's very
Okay, talk to each other. You can talk to each other. It's okay to ask your friend, oh, I don't know how to start with this.
reactants are floating together.
And by the way, this question was asked in one of my exams. You will find it in the practice exam.
And if you react Fe with any of those, it will stay.
Okay, so I'll stop it at 3 minutes. Okay?
What?
Okay, so let's stop it right here and check what you think. Here we go. So we have 78% for A and a little bit for B and C. And yes, A is the right answer. Okay, so let's get started. How we think about this? We have Fe3, barium, and chloride. So if I added sodium sulfate, which is Na2SO4, but I'm thinking now about the ions. If Na is added with Cl-, it's not going to form a precipitate. Fe3 plus sulfate, so if we go to the solubility rule, let me make more space in here. So I'm going to start with the first choice. So if I add Na to SO4, what I'm going to form is Fe2SO4 3. If we go back to the solubility rule, this is soluble. Now this sodium sulfate with barium, it's going to form the barium sulfate, and this is insoluble according to the solubility rules. So this is what exactly I want. I want the Fe3 plus to stay in the solution and the barium to kind of precipitate. And this is what usually chemists do if they are in kind of certain companies that they need to get rid of certain ions that they are either toxic or they want to clean the water or decrease the hardness of water. This is kind of the process that they do. They figure out what they need to precipitate something and keep the other ion. Now if I go to the second choice, which is C, I'm going to form iron PO4 and I'm going to form barium 3 phosphate 2. Both of them are insoluble, and that doesn't specify what this question is asking about. And for the last one, KCl, there will be no precipitate at all because I'm forming barium chloride and iron chloride, which both of them are solid. Okay? So let's do another one, the same type. Okay, and Jake, what about starting taking cards? I'm talking and somebody's still talking in the class. Okay, let's go to the next one. It's again an eye clicker, same concept. Where is it? So, if an aqueous solution of A or B or C is added to a mixture of barium chloride and iron chloride, the iron ion will precipitate, but the barium ion will remain in solution. So I'm reversing kind of the question. This time, I want the iron to precipitate, the barium to stay there.
Yeah, what do you think?
So 75% for A. A is the right answer. Okay. Again, we're gonna use the same strategy. If I add NaOH, the Na with Cl minus is gonna form NaCl, and that's not what the question is asking about. If the OH minus, if it reacted with this, it's gonna form. Just have to wait for the laptop to start freezing. Okay. Okay, so let's see. So I'm gonna rewrite everything before I upload the PowerPoint today. Anyway, let's go back to this one. So I have Fe3 plus, I have Di2 plus and Cl minus. So if I add the NaOH, what I'm gonna form is FeOH3 and barium OH2. If I go to the solubility rule, all hydroxides are insoluble except those with barium. So this is soluble, this is insoluble, and this is what exactly the question is asking about. It's asking me about that the iron will precipitate and the barium will stay inside the solution. And so this is A is the right answer. Definitely, you can keep trying the others to figure out. In the others, either both gonna be insoluble or both soluble. So you're gonna go through the choices for such kind of questions. You have to go through the choices instead of just doing the calculation or doing the whole process. With that, we're done from precipitation reaction, and we're gonna start with acid-base reactions. But before we go any further, I know most of you know what is an acid. Just as a reminder, an acid is something, there is more than one definition for an acid. The first definition is by Arrhenius, and there is another one by Lowry, and they are two different scientists. They defined acids in two different ways. Both of them, for the acid, both of them, they said, okay, the acid is something that releases an H+, a proton. Now, the characteristic of acid, it's solid, it tastes is solid, it reacts with metals, and it reacts with calcium carbonate. This is the definition of an acid. So let's say HA, any acid, and A means any anion. Any acid would react, for example, with magnesium to give magnesium A. It depends, definitely this is not balanced, it depends. It's going to be, that's not balanced, plus H2 gas. And any acid, I'm going to take HCl, would react with calcium carbonate to give calcium chloride plus H2O plus CO2. So this is by definition what is an acid and what is, and this is definitely a gas, that's a liquid, and this is going to be water soluble. So this is the definition of an acid. It's something that releases a proton, that gives a proton one, it has the ability to release a proton. And definitely all acids react with metals. It's not only magnesium, any other metal, they will react with it. It's gonna react with calcium carbonate. Now, what is a base? Now, when we come to the base, there is two scientists, two definitions. The first scientist, it says that a base is something that releases, when I put it in water, it's something that gives an OH minus. And this definition by Arens. This is the definition of a base. KOH is a base, and AOH is a base. You name it, anything with an OH minus that can be released is a base. Now, according to Bronsted-Lowry, a base is something that accepts a proton, which is a little bit different than this one. An example of a base, according to the description of Bronsted-Lowry, is ammonia. Ammonia plus an H plus, which is a proton, it gives ammonium. In other words, this ammonia, which is the base, accepted a proton. And this is the definition of a base according to Bronsted-Lowry, which are two scientists who work on definition of bases. So what is base? It depends on the definition. It could be this or that. Some of them, they satisfy both. They can accept a proton and at the same time they can release OH minus. Usually weak bases are the Bronsted-Lowry bases, and kind of the only two weak bases that we're going to talk about in this course is ammonia, and another one is carbonate. This is another weak base. With H plus, it's going to be H3O minus at least. So this is the definition, the two definitions of bases. This is the table we talked about in detail when we were talking about electrolyte. You need to know what is the weak base, what are the strong bases. You need to know the strong acids, what are the weak acids, because that's going to affect how we're going to write the net ionic equation of acids and bases, which we're going to do on Monday. Okay? So enjoy your weekend, and I'll see you on Monday.